name is Pius Magari. My group members are Branislav Tokovic and Sadman Wakil, and today we will be doing a presentation for the durable residential portable power system. We did have some outlines that we were supposed to talk about, and under the outline we do have the main objective. We do have the product strategy and target market. We also have the design goals that we will talk about later on as the presentation, as we keep talking. We also talk about the problems we encountered and the solutions to those problems. We added miscellaneous parts like the fuel adapter and how we installed it and got rid of the old one. Paint job, which is really, really important. We're going to talk about that later on. The frame and the weather shroud, my colleague's going to talk about that as this, we keep progressing in this presentation. Well, the objective. Well, before you design and come up with a product, you got to have objectives. And one of the objectives was to design a generator that will have an output of 6 kilowatts surge and 4.8 kilowatts running. And we did purchase a generator that had something close to that, which is 5.2 running and 6,000 surge. And some of the objectives that we tried to put in effect were the tri-fuel capabilities. Tri-fuel basically means that this product is running on 3 fuels: gasoline, propane, and natural gas. And how can you achieve tri-fuel capabilities? You're gonna purchase a fuel adapter and the regulator, the tri-fuel kit. That's how you're gonna achieve the tri-fuel capabilities. And our product really fulfills the National Electric Code. Without fulfilling the National Electric Code, it would be really unsafe for us to put this product in the market so clients can purchase it. Okay, product strategy. Product strategy really, we narrowed it down, and the strategy was mostly for safety and the automatic voltage regulation. We installed it in the generator. This transformer is inbuilt. It's from 1 to 240. We also have the rectifier that produces 12 volts of DC, surge protection, low engine level and cutoff, and also has a carb compliance, which is really, really safe for the consumers. As you can see, the distribution, we did one-on-one talk. We're intending to sell this product online and also through catalogs. Yeah. The target market. Basically, I probably spoke about this before just like 2 seconds ago, but who are we really targeting for this product? We as a group of 3 guys, we came down and realized that since we are new in the market, we will try to sell this product to homeowners, small business owners, emergency services like hospitals or firefighters or police rescuers and medical teams, and also people who live in areas that are frequently hit by severe weather like tornadoes or hurricanes, weather, climates, areas with that sort of climate. The design goals. Now I will give my colleague Sadman Wakil, and he will be talking about the design goals.
All right, thank you, Pius. So I'll go over the design goals. And so as Pius already mentioned earlier, we need the tri-fuel capability. We also need a continuous power output of 4.8 kilowatts and also a surge output of 6 kilowatts. And also the engine noise should be below 90 decibels. Should have a manual engine start. Also the weight of the product should be within 240 pounds. And also the dimension should be 4 feet high, 4 feet long, and 3 feet wide. And also more of these design goals, as you can see. So the product should be able to run for 8 hours continuously, and also it should be able to run for 30 days without human interference. It should also have a useful operation life of 10 years. It should also be able to generate 40 amps of single-phase electricity at 120 volts and 20 amps of two-phase electricity at 240 volts. Should also have less emissions. Should also have a 13 horsepower engine. That was based on the electrical output calculations, which was actually a 10 horsepower engine, but we wanted to be on the safe side. And also, as Pius already mentioned, we need a 6 kilowatt alternator for the storage output. Should also have 3 outlets, 2 flat free tires. Should have 1 adjustable handle for cooling. Should have a low oil indicator switch, and also we should have a weather shot for severe weather conditions. And also we have encountered some problems. So starting off, we had a tight budget, and some of the parts, such as the engine and the alternator, they actually cost much higher than expected. And also and for every problem, there should be a solution. And ours was to buy a used generator. So basically, we bought an ETQ TG5250 portable generator. And basically, what we did is we used some of the parts, such as the engine and the alternator, for our design. And also, this was the best choice. And most of the features were what we originally intended. And also, the engine of this ETQ generator was a 4-stroke engine, which was very important for tri-fuel capability. And also, comparing the ETQ generator with some other generators that we found on the market. So this table shows the comparison. So the ETQ generator had 11 horsepower. It also had the desired electrical output. It actually had 5.2 kilowatts of continuous output, which was more than what we actually intended. And also it had the lowest price of $250, and it was also a 4-stroke engine. So the fuel adapter, we bought it from Century Fuel Products for $199. And this had the tri-fuel capability of running the generator on liquid propane, gasoline, and natural gas. And also the whole kit of this fuel adapter came with the pressure adapter hose that needs to be connected to the bottle of liquid propane. And from this picture, you can see the whole kit of the fuel adapter. And also, we installed the fuel adapter ourselves. So we used basic tools such as pliers and screwdrivers. And the fuel adapter kit, it actually came with a very good instruction manual. And this is a picture of when we were actually installing the fuel adapter. So and this is the regulator. And the paint job we also did ourselves. So we bought all the necessary parts from Lowe's and Home Depot. And before painting the generator, we used the scrub to clean the surface. And before actually painting, we actually primed the surface for 24 hours. And we used high heat black paint for the muffler, because when the engine runs, the muffler gets very hot. And here's a picture of the process, actually when we were actually painting the generator. So you can see all these papers. And miscellaneous parts. So we needed some parts to actually get the generator running. So basically, as Pius probably mentioned earlier, we bought an new air filter. We also bought a pair of rubber feet for stationary positioning. We also purchased a low oil indicator switch, and also we bought 2 pairs of receptacles. And for the next part, Pius will talk again.
As what Khalid just said, we went over this earlier. This generator will have 3 outlets. Basically, 3 outlets are the two 120 volt receptacles with 20 amps, with 20 amps parallel. They're running parallel, and also the 240 volt receptacle for heavy duty loads, and it has a circuit breaker of 22 amps. Before I say 20, it's supposed to be 20 amp circuit breakers. And you can see, as you can see, this is the engine switch, the auto throttle, and voltage selector. The circuitry, as we said before, it has 5 outlets, and there are 2 duplex 120 volt receptacles, and 120, 240, 222 amp receptacle for heavy duty loads, which is all single phase. This is circuitry. It was designed by Schemit. Is a software. This is the picture. And the frame, I will give it to Mr. Branson Tokovic to elaborate.
Well, good afternoon. I'm gonna talk about the frame right now. We designed the frame. Actually, we adjust our frame according to design of our weather shaft. First, we design our weather shaft, then we adjust the frame in order to suit, in order to put our weather shaft on the top. Now, the next slide, I'm gonna show you. This is the old how it used to look when we bought our generator. And the next picture. This is the new. This is actually our design, and this is how it looks in reality when we're done with the welding and readjusting of our frame. Next, and this is about the weather shaft. In order to make our weather shaft, we use the wood, fiberglass, and fiber cloth. First, we put on the wood fiber cloth, and then a few layers of the fiberglass, and then we painted it. And now this fiberglass made very strong layer, and now makes water resistible. Water cannot go through our weather shaft. Now next, and this is our design, CAD design of our weather shaft. And on the next picture, you're gonna be able to see how this was. This is the wood, and this is the fiberglass, and this is the first layer of our fiberglass. And on the next picture, you're gonna see this is how it looks like when you're done. This is during the painting, and this is on the top of our generator, and this door protects our electrical panel. And this is here, comparison of the features. This is online design goal, and this is accomplished design. And now if you compare, actually we have better features in our accomplished design. Here only is a little bit lower horsepower, 13 versus 11, but it still have better features. And now conclusion, my classmate Salma Vakil, he gonna continue. Thank you.
All right, thank you, Branislav. So it is me again. So concluding the presentation. So actually, as Branislav actually mentioned, our prototype actually has better features than our intended design goals. And also, we have encountered some problems at the start of our project, especially to do with the cost and how we would actually manufacture some of the parts. But we actually came together as a team and solved all our problems professionally. And we're proud of our accomplished design goals. And for the next we have the demo.